Hello, my name's Jing Chang. So today I'll be introducing the generative algorithms. Basically, the pipelines we will use in this workshop. So first, I will introduce a bit of myself. That's my journey from engineering to now. So that initially I will study engineering before architecture for 2 years. Then I transferred my major to architecture and graduated from the University of Hong Kong for bachelor and graduate school of design in Cambridge for master. And then I worked both in US and in Shenzhen for like 4 years. And currently I'm in academia. So that my current interest is the it basically means kinetic architecture responded to the embodiment and its relevant pipelines. I recently just organized all the points I've been worked a little bit on. So my main interest is the kinetic intelligent architecture algorithm framework. So the pipelines of the kinetic architecture. So if we break it into parts, it will consist of embodied sensing, design algorithms, and some output pipelines. And today we'll be mainly focusing on the design algorithms, so the generative algorithms part. Well, first of all, I personally classify the digital design technologies into 6 levels, from geometric level to algorithmic or cybernetic level, and then to parametric level, and then to syntactic level, neural, and recently the large language model and multimodal. So geometric, it basically means the modeling in Rhino. Examples are NURBS and MASH. And algorithmic means geometry generated by explicit logic or rule. So the key examples are L systems and cellular automata. And we used, like, more often we use the parametric design, so that's quite a common level that we'll be using, just like the parametric facade. We usually design in the company. And then it's the syntactic level. What is different now is that it will not only focus on one thing, one geometry. It starts to involve designs that defines by organizational rules. So it means it does not only mean one thing. It means the collective algorithms, and then the neural. Key examples again and machine learning, and then the LLM and multimodal, such as the text to image, text to 3D, or conversational agents. And for the generative algorithm, we will be introducing today, basically will span from algorithmic to syntactic level. And I just classify some key algorithms for this part, like the L system, cellular automata, and slime mode algorithms, edge bundling, or flocking simulation. But today, I will be mainly introducing this applicable pipeline. So from slime mode algorithm to generate paths, and then use edge bundling to refine paths. And probably if we want to refine the geometry more before feeding the geometries to Midjourney or Xfigura, we could use Amoeba or some plugins that Carlos will introduce tomorrow to refine the geometry locally. And so what is slime mode algorithm? I think the Tokyo subways use the slime mode algorithms to design their lines. So basically, in this algorithm, you have to define two sets of the points. One is the the destination. Well, in the well in the definition of the algorithm is called food, and the other one is the emitters, the emitter points. So you also need to define an environment. So basically, it's mimicking the way that the slime mold to find their food. So it will calculate the most efficient paths for between these two sets of points. So in this example, um, we ran 3 times of the slime mold test to come up with um, this complex network of lines. Well, actually, you can always in practice you can always control the time, control the parameters such as the birth rate or the death rate of the slime mold, and then the calculation time uh, to sorry to achieve the best design outcome that you want. And then after you have this quite complex path, like you will need to use the edge bundling algorithm. Well, it's very Chinglish algorithm here, but it's officially it's called edge bundling algorithm to refine this quite complex paths. And the free auto actually has done these experiments physically. He used the wools to he used to well this the wools are fixed in these points, and all these fibers inside this circle are the wool fibers, and then he made the wool wet so that the adjacent wools will come will coming together because of the water, because of the attraction of the waters. So they use these physical forces to refine the organizational network of the wools. So in the Grasshopper, we use the Kangaroo plugin to mimic this physical force. So so in this example, following from the previous network here. Well, it's hard to say, but we refine the lines, the paths a little bit, and used. You can see from I think from here to here how how the paths that are adjacent becoming one major road, so that instead of like multiple paths in this certain area, it just be refined thinner. It just be refined into one unified path. So after you have these paths, well, in a different example, you can always come into the geometries within the path or of the path itself to refine the geometry. In this example, we used the Amoeba, that plugin from RMIT. I think Nabi comes from the same university, and for in that. I will also introduce that plugin tomorrow. So in that plugin, you will need to define the force directions, and the proportional force proportional force factors, and the force directions, and then it will calculate for you what's the best geometry under that force, what's the best and the most efficient geometry under that force. You can see from the original and then to the final result. And then coming to the AIGC part, like I will be introducing like how the AIGC has been developed since 2023. That's examples we produced in the A Business School in Hainan in 2023. So then this example in Rhino, in the actual Rhino model, we used Rhino and Amoeba plugin to generate the geometry. We only have the massing model. And then we used the Midjourney as a ideation mode, as a reference image to fit in the stable diffusion web UI, the stable diffusion I don't think people are using Stable Diffusion quite a lot these days because there are more and more softwares or platform with better user interface. So, but that's what we have almost 3 years ago. Not very easy to control, but it's okay. It's okay. It's representable at that time. And then in the late 2023, uh, because at that time the mid-journey are not very controllable, so we mainly use Stable Diffusion to make these adjustments in one project because the AIGC, one of the pinpoint of using AIGC to produce the final images is hard to make it consistent. But in the practical projects, like we have to make uh, the 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 final design unified and consistent. Yeah, that's what we had at the time. And uh, also at that time, we used this pipeline in the project. Well, this project and the next project will be the example project of this workshop. So let's target to have a deliverables of this. So in this project, it's actually a competition entry for the NEA and Anthony Gaudi Foundation. Uh, like it's held by these two organizations, and the competition is also called Biomimicry and AI. And so in this project, we use the slime mold algorithms to find the most efficient uh, the energy transit path for also for a place who is suffered by the floods. So we designed this sort of new city on the sea, and we used quite a lot algorithms at that time, and mainly used the Stable Diffusion for the images for the but we do but for all the line works it's basically do it basically done manually. And then 1 year later in 2024, uh, at that time, the Midjourney Pro really make the images quite easy to edit and quite easy to retexture. So at that time, we also we refine this pipeline. We not only use the slime mold algorithm, we also use the kangaroo. We use edge bundling to make the paths more clear and more efficient. And that's the outcome 1 year later. Similar project, but the site is it's not only in the sea, it's in the ring. So yeah, well, so basically uh this workshop is targeted to have a deliverable of this, like using the similar pipelines. But if you have more, if you have some like other ideas, but you have some other plugins you want to try more, and you're welcome to discuss like this additional ideas with us, and we are open to that.